Our quiz for today comes from some of the questions people have. They seem to be pretty much okay with reducing a matrix to this upper triangular form, which is sufficient to get a solution, okay? Because you just write out the equation, z equals -3, y plus z equals 4. You start there, you plug -3 in for y in the equation you get here, you're going to be able to, for z, plug -3 for z into the equation you get from this line, and you're going to be able to solve for y. Now you've got values of y and z to plug into the equation you get from this line, and you're going to get x. Okay, so that's going to work out. But I've seen some work out there that looks like all the right operations were done, and I've looked at them and done calculations in my head, but somehow you're misleading me effectively enough. And I'm really easy to mislead these days. Okay, so let's just see. Okay, so what I want to do, and this is of course explaining it for everybody, is I want to add -5 times this row to this row. So I want to do, row 1 is going to remain intact for now, and row 3 is going to remain intact, but row 2 is going to become row 2 minus 5 times row 3. So I'm just going to copy row 1. Well, I'm going to have the 0, 1 because there's nothing down here to get rid of that 1, but then the mystery is what numbers go here and here. So let's add row 2 to -5 times row 3. Okay. Row 2 is 0, 1, 5, 4. -5 times row 3 is, it's pretty easy, 0, 0, -5, 15. And I think maybe one thing that I saw in the solution I looked at was maybe we missed multiplying -3 by a -5. Okay, that's really easy to do. See me do it. Okay, so you get then 0, 1, 0, 19, which tells you that y equals 19. Okay. So, assuming I did that correctly, and that's a pretty shaky assumption, I now want to get zeros here and here. Now I can do that all in one step, and I'm gonna, but if you want to break it into 2 steps, that's fine. Okay, the first thing you want to do, of course, is do this row -3 times this. And actually, what I just said isn't so. Okay, so anyhow, we're going to do -3 times this row plus this row. That'll give us a 0 here. So it's going to be 1 minus 3 times row 2. Okay, so we write row 1, which is 1, 3, 7, 2, and -3 times row 2, which is going to be 0, -3, 0, careful, -27. Adds up to 1, 0, 7, -25. Then we're going to add, okay, well, I'll go ahead and do that. We've got 1, 0, 7, -25. 0, 1, 0, 9, 0, 1, 0, 0, sorry, 1, -3. And then finally, we're going to do row 1 minus 7 times row 2. Now, I think what I was saying was a lot of sign errors, negative times negative. Okay. So you just got to be careful about that, and it helps to write these things out over here. So over here, I want these in a column so I can follow. But over here, I'm going to have row 1, which is 1, 0, 7, negative 25, and negative 3 times row 2. Let's just make sure I line these. That wasn't going to work. Again, row 1 is 1, 0, 7, negative 25. And negative 3 times, or negative 7, it'll be not negative 7 times row 2. Negative 7 times, and it's not row 2, it's row 3. See how easy it is to make a mistake? I got what I did in my head here, and somehow it's coming out in the wrong place. So you got to be very careful. Do like I don't. Okay, you got to get 0, 0, negative 7, and you're going to get plus 21. And that's going to give you 1, 0, 0, negative 4. So I think we get 1, 0, 0, negative 4, 0, 1, 0, 9, 0, 0, 1, negative 3, which means, I'll just write it here, x equals negative 4, y equals 9, z equals negative 3. So up here, I'm going to say solution. Negative 4, 9, negative 3. Check. We check with the matrix we started with. And of course, if you reduce something else to get this matrix, you'd have to check in the original matrix. But just taking this matrix as our starting point, original matrix got this equation. This would be like equation 1. Let's see if our solution works here. Okay, negative 4 for x, 9 for y, negative 3 for z. 3y would be 27. That'd be negative 21. And that would be, make it negative 25. 27 minus 25 is 2. So that's going to work. So it's safe to write down the second equation. Well, I'll just substitute for the first equation. Negative 4 plus 3 times 9 plus 7 times negative 3 equals 2. And I'm going to say that checks. You want to simplify it, but you're going to get 2 equals 2. Okay? Now, I haven't written down the simplification on the left-hand side, but everybody can do that. You do that using your calculator if you want. Now, I do encourage you to do it in your head, because none of these numbers are very big. They're all numbers that are pretty easy to deal with. And we really need to be able to use our heads. But the calculator is a great backup. Okay, the second equation is corresponding to the second row is y plus 5z equals 4. Well, I'm 99% certain this is going to check, because I use row 2 and row 3 to simplify row 1. And if either of these rows had been off, my row 1 wouldn't have given me the identity. Still, just to be sure about it, y is 9. And that checks out. Because 5 times negative 3, oh, it's negative 15. Wait a minute. It doesn't check out. I'm sure that was going to check out. What's wrong here? 9 plus 5 times negative 3 is 9, and negative 15, which is 6. Did I copy it down right? Yeah. Well, that's a pain in the behind. So I was 99% sure that was gonna work out. Doesn't work. Better not put an X there. The X over there, you'll confuse it for variable. Am I doing something really dumb here? It's entirely possible. Third equation, of course, checks. Okay, well, let's just pull out the big guns. And write the equations. Okay, now, I guess I'm gonna put the board up here just to write out the equations. Okay, one equation, first equation is x plus 3y plus 7z equals 2. Second equation is y plus 5z equals 4. Third equation is z equals -3. Well, we plug this in for z, and we get y plus 5 times -3 equals 4. 5 times -3 is -15. That's going to give us y equals 19. Now over here, I got 9 when I added -5 times row 3 to row 2. Uh-huh. See that 19 there? Would have been much better if I'd written down that 1 in front of the 9. Because now we agree, and now everything else, or at least some of the rest of it, changes. Now, how we managed to get the right solution up here, well, I can kind of see how that happened. Okay, so we had 19 here, and we would have had 19 here. And then when we finally did -7 times row 3, it would have been, what's our row 2? Where did I didn't write down what I'd done here, but that's row 1. So that's -3 times row 2. And instead of -19 here, I should have had -57. Which gives us -55 in this step. Then if we have 107, -25, that becomes -55. And I add 21, I get -34. So now I would get -34 here. And then 27 and -21 doesn't work at all. There's still something wrong. Okay, well, let's just see. Okay, wait a minute. Y was 19. 3 times 19 is 53. So I've got negative 34 plus 53 is 19. Minus 21 gives me 2. So that still checks. So I think I've corrected the solution, and you see the need for checking. I pretended to make a mistake by not writing down the 19 when I got a 19. And I wasn't really pretending, I just didn't write down the 1. Okay. So now let's try the second equation, which ought to be y is now 19. 19 and 5 times negative 3 is negative 15 does give us 4. So I've got to erase all the bad words I put down here. And say, okay, that checks. And then, of course, y equals negative 3. We already know that that was, then it's the third equation, and it checks out with the solution. Okay. Now, just to go back to the upper triangular form. The upper triangular form gave us these 3 equations, and you see that we take our z equals 3 and plug it in here, giving us a 5 times negative 3. Then we have the y and we have the 4, and it does come out with y equals 19. So by going back to the upper triangular equations, I was able to see pretty quickly where my error was in my row reduction, and it did check out. But let's go ahead and complete this. It's only one more step. So we take y equals 19 and z equals 3. We plug in our z equals 3. We plug in our y equals 19. And out of that, we get the equation x plus 3 times 19 plus 7 times negative 3 equals 2. Well, that gives us x plus 57 minus 21 equals 2. X plus 36 equals 2. X equals negative 34, with which checks with our solution. Now, when I wrote this down, I wasn't being very careful. I mean, I knew I had a negative 34 here, but I never wrote it down. That is what our third equation gives us. So let's get everything written down correctly. Okay, so there's the first equation as it should be. Negative 34 and negative 21 gives us negative 55. 3 times 19 is 57. 57 and negative 55 is 2. And you can write that out. Okay, so we see as usual, it's easy for me to make mistakes. So it's going to be easy for you to make mistakes. I'm giving you a bad example here. I'm setting a bad example. So, on the exam, if you happen to have a 3x3 matrix that you need to reduce, I'm probably going to ask you to do one of 2 things, which just reduce it to upper triangular form and then solve it that way. Or I'll have it reduced to this form and you need to take the solution from there. Probably. Now, if it's one where I give you the original matrix and you have to reduce it to upper triangular form. If you want to continue and do this, that's okay. Because it's real easy to solve in upper triangular form. I don't think anybody's going to have any problem with that if and when they encounter it later. All right. We okay? I mean, everybody, did a good job of following the process. Some of you were even worse than I was. I'm not sure. I think I was as bad as anybody. Okay. If you're worse than I am, you're pretty bad. Okay. Okay, well, let's do the last thing about matrices. Okay, here we have a row, here we have a column. This might be a row of a matrix, this might be a column of a matrix. We can multiply row times column. We can also multiply column times row. The column's first and the row is second, but that gives us something much more complicated. And I'm not going to show you that because you're probably never going to get into tensor analysis, and if you do, you'll understand it pretty quickly. Okay, so anyhow, we have this row times this column, and let's see if you can see what I'm doing. Here's 2 times 5 plus -1 times 3 plus 4 times -2. And of course, then we can do the arithmetic and get 10 minus 3 minus 8, which is -1. Okay. Now I'm going to give you another row and column and see if you can figure out what I did. It's going to be the same anytime. Okay. See if you can figure out how to multiply that row by that column. Look at what I did for the first one and do the closest thing you can to what I did, and you get the second one. Well, that's done very well. I think everybody wrote it down correctly, and everybody sees the pattern. We multiply the 3 by the 7. Then we multiply the -1 by the 3. And then we multiply 2 times -2. And then we multiply 4 times -1. And that gives us what? 21 here, -3, -7, -11. I get 10. Did you get 10? Did you add them up? It's okay.
I didn't finish it.
People in the hall keep answering my questions. I don't know what's the matter with these people. I think if you add it up, you get 10. Okay. But I only think that because I did it once in my head and didn't check it. Still, that's pretty easy. Okay. Now, we're going to do this. And this is probably going to be a little confusing, so I'm not going to ask you to puzzle out what we do with this. There are many things you could think of doing, but once I show you, it's pretty easy. Okay, this is what I think we get. The -1 here is just what I got when I multiplied this row by this column. Okay? And this row is the same as this one, and this first column is the same as this one, right? So I know that this row times this column is this. Okay? Now figure out what the second row times the second column is. If I did it right in my head, it should come out -20, but you know, it came out of my head, so it's subject to closer analysis. Okay, so what I have is I have a row multiplied by 2 columns. Is that clear? So here's what I get when I multiply row 1 by column 1. And here is, and I said row 1, but we only have one row, so there's no point. Okay. And row times column 2. Make sense? Let's try. This matrix times this matrix. This is called a matrix. This is called a matrix. Matrix has a certain number of rows and a certain number of columns. Well, I'm actually going to do this one because I think you're going to understand it rather than making you figure it out, because you might take a wrong turn there and you find that a little bit confusing. Okay, so over here to the side, row 1 times column 1 is 2, 3 times 1, -2. That's 2, that's -6, that's -4. Agree? Okay, row 1 times column 2. Column 2 is -3, 4. Row 1 is 2, 3. We're going to get -6 plus 12, which is 6. Okay. Well, are we done? Think there's something else to do? Well, yeah, we haven't done anything with row 2. We better multiply row 2 by each of the columns. That's going to be 4, -3, multiplied by 1, -2. That's going to be 4 and 6. That's going to be 10. And then row 2 times column 2 is 4, -3, multiplied by -3, 4. Okay. And that comes out, what, -12, -12, -24. Okay, well then this equals. the numbers we get from row one are gonna go in row one of the product. The numbers we get from column one will go in column one of the product. So row one times column one is -4. That goes here because that's starting our first row and our first column. So from row one, column one, we get the number in row one, column one. What do you think I get for the number we get from row one times column two? Well, it goes in row one and column two. So 6 is going to go here. That's column two. So row one times column two goes in row one, column two. And then row two times column one, well, we better put this in row two and column one, which is right here. So that result is going to go here. Row two times column two. Where's it going to go? Well, the only place it's left, but that is row two, column two. That gives me -24. Okay. And let's emphasize this is row one. This is row two. Column one. I don't know why column has to have so many letters in it. I don't have room to write it. And this is column two. Okay. Now, if I gave you a matrix with 10 numbers this way, 10 columns and 14 rows, well, you would get 14 rows and you would get 10 columns. You'd have 140 numbers to fill out. And hopefully you would be able to use a machine to do that because computers have been able to do that right from the very beginning. Okay. It's one of the most fundamental things you do with computers is manipulate matrices. Okay. So the rules are pretty simple. Not at all difficult to follow. Now, I'm going to throw a little bit of a curveball at you. So let's say we got the matrix multiplied by a single column, X, Y. Write out what you think we would get from that. And I would start with saying row one times the column. You don't have to call it column one since it's only one column, but you could if you wanted to. Okay, column or column one, only one column. And then row two times column one. Okay. Okay, now we've got pretty good results here. Some people try to shortcut this a little bit. You really want to not shortcut things. You know, you see I'm writing out row times column, right? And I'm doing it carefully. Now, after you've done half a dozen of these, you know what the pattern is and you're not likely to screw it up. Okay? And you know, most of what happened there was yeah, it's just a matter of trying to shortcut. So it's 1 or times X, Y. That equals 1 times X, and then the 4 multiplies the Y. It's real easy to get it in your head that, well, first row has X in it, so multiply both these numbers by X. But that's not the pattern. I've only seen the pattern briefly. You wouldn't have done that if I had numbers there. Okay, you wouldn't multiply both of these by 1 in this case. Maybe you would have, but if so, don't admit it. Okay. Fair enough? So this becomes, well, that's first row times the column. Then row 2 equals -2, -3. Multiplied by the column x, y, which is -2x minus 3y. Okay. Now, let's say that I have an equation. I say that this equals 5, -7. Well, this matrix times this matrix, I call this a column vector. So just a single column, then I can call it a column vector. It's what it's often called. It's got multiple columns, then it's a matrix. Got a single column, then it's either a column or a column vector. Could call it either. So I'm going to consider this a column vector. Row times column vector equals this result. Okay, well, what's that saying? How could these two be equal? Well, the only way this matrix could equal this column is if the first row equals the number in the first row, and the second row equals the number in the second row. Okay, so this means these are equal if and only if 1x plus 4y equals 5, -2x minus 3y equals -7. Okay. So this matrix equation is equivalent to this system of equations. This matrix equation up here is equivalent to this system. A lot of times, the easiest way to get a solution to a system is to convert it to a matrix equation. And then solve it by multiplying both sides by the inverse matrix. You don't need to know that. But it's like this times this equals this. It's kind of like then this would be this divided by this. Well, you can't divide by a matrix, but you can multiply by its inverse. You don't need to know that, but that's where the picture goes. So what I'd like you to do is convert a matrix equation now let's just take an equation. Okay, so I'm gonna ask you to write this system here as a matrix equation. Okay, so we're trying to find the equation for this, the logarithmic equation for this curve. We got y equals a times log base b of x minus h. We've got the two lines, x equals 12, y equals 4, in the set of coordinate axes. So what are we going to do here? We're not going to get a precise result, and you don't get a precise result from pretty much any graph. Okay, but we want to be able to estimate this so we can understand the log function a little better. So if x equals 12, if we get a point on the graph, then we have an x and a y we can plug in, right? Well, I'm a little low there, but okay, on my graph, I've got y equals 4 here. I'm going to say if I go all the way up to this, that should be about y equals 10. So the point 12, 10 is on the graph. So 10 equals a times the log of 12 minus h. And there we have one equation. Now we need three equations because we have to figure out what a is, what b is, and what h is. And we're going to have to get two more equations. Now, where I would start is either I'd start with some point on the graph and the y-intercept, because there x equals 0, and the vertical asymptote. I would actually probably start trying to estimate the vertical asymptote. We can do these in any order, it doesn't matter. Okay, so the vertical asymptote approximately x equals, if that's 12, there's 12, x equals -9. Different than the estimates other people made, but yeah, not everybody drew the curve the same way I did. Okay, and all the curves looked like good logarithmic curves. Some of them a little further to the left, some a little further to the right, and that's okay. Okay, so vertical asymptotes at -9. The vertical asymptote of a log function, the square log function, is always at the y-axis. So any log base b of x the y-axis, vertical asymptote for any log function where you haven't shifted it is the y-axis, which is the line x equals 0. Now remember that the log function is obtained by just switching the coordinates, swapping the coordinates of the exponential function. And the reason the log function has an asymptote there is because the exponential function has an asymptote here. The negative x-axis, when you swap coordinates, becomes the negative y-axis. Okay, so shifted log function, so your horizontally shifted log function is at x equals h, because the y-axis is shifted to the vertical asymptote. Okay, vertical asymptote is h units, whether h is positive or negative, could be left, could be right. Here, so on any graph you see, it's going to be either obvious or something you can estimate reasonably, the location of the y-axis. Okay, badly formed sentence there, but I think the meaning's clear. So now, vertical asymptote's -9. So h equals -9. So we got n equals a log base b of 12 minus 9, which is log base b of 3. And then we have the y-intercept. I'll use y equals 7 because that's pretty reasonable there. Okay. Even though somebody else out there used y equals 7. And it was pretty reasonable there too. Okay, y-intercept 0, 7 implies 7 equals a log base b of 3. Well, now we have two equations in unknowns a and b. Something's wrong. Oh, sorry, that was stupid. Should be log base b of 0 minus h. Which is a log base b of 9. I wrote the 3 down here pretty mindlessly. Okay. X was 12 here. Oh, man. That one's okay. This one isn't. Okay. Being careful. A log base b of 12 minus 9. No, h is minus 9. It's log base of 12 plus 9. So it's a log base b of 21, right? Now, again, my error there kind of confuses the process. From a point, we get an equation. From the vertical asymptote, we get an equation. And that equation allows us to evaluate, it tells us what H is. The vertical asymptote tells us what H is. And then the y-intercept gives us an equation. Okay. So this equation is 10 equals a log base b of 21. This equation is 7 equals a log base b of 9. Now we solve these equations. I like to divide this equation by this equation, which eliminates a and allows us to solve for b. But since your method of substitution has been kind of emphasized, we're going to solve for a. Okay, so we solve for a, we plug it into the second equation. Second equation then tells us that 7 equals 10 over log base b of 21 multiplied by log base b of 9. So you get 7 equals 10 times log base b of 9 divided by log base b of 21. Might be mixed up here. I don't think so. Okay. Well, that means then divide both sides by 10, you get 7 over 10 equals log base b of 9 minus 21. And you can't take log base b of a negative number, so something's wrong here. We're out of time. And something must be wrong in one of these equations, but h is negative 9. The point is x equals 12, y equals 10, that's fine. Your log base b of 21. Seven equals b of 9. Unfortunately, my brain is in a bad loop here and something isn't right, but this procedure is what you want to do. Identify a point, get an equation. Identify your y-intercept, get your horizontal shift for a logarithmic equation, for a logarithmic function. And then generally you want to use your y-axis because it's pretty easy, okay? I don't see anything wrong with these equations. Everything seems to make sense. But I've got to make sense of it in a little different way and get my brain out of whatever loop has caught it, whatever loop it's caught itself in. Okay.